allowed to perform this action. You are not authorized to execute this file. You do not have permission to change this configuration file. Did you get angry? Yes? Well, then this is exactly the right talk for you. Welcome to, well, that escalated quickly, a penetration tester's approach to privilege escalation. But before diving into the topic, I have a question for you. How many of you are penetration testers? Nice. Who of you uses BitLocker or a similar tool for volume encryption? Please raise your hand. Very good. I didn't expect less. And who of you uses pre-boot authentication, meaning he has to type a password when starting his machine? Still the majority. For all those who didn't raise their hands, I have a surprise. So, first of all, why do we want to escalate our privileges? So, we as penetration testers, attackers, we usually get access to a system with a low privileged user. So we are able to exploit a certain service, and then we have a user on the system. But to be fully operative, to start TCP dump, to look into all of the files, we want to have the highest privileges possible. During my research, before I did my OSCP, I noticed that there is not that much literature about privilege escalation, especially about Windows privilege escalation. So I thought to myself, why not do some research in that topic? So the main goals of this talk is for you to learn different principles and concepts that help you next time in your assessment to escalate your privileges. And for that, I will provide a practical and systematic approach on how to do that. But before diving into the topic, a short reminder about some Windows basics. The registry. The registry is a very big database that is composed of keys and values. The highest values are called root keys, which you can also see in this picture. These are the root keys of the registry. And these keys again contain subkeys, which again could contain further subkeys or then values. The registry stores important data like system-wide software settings. It contains the security database with different passwords in it, and it contains per-user configuration settings. Every key is protected by an ACL. So you can granularly define who is able to read and modify or even delete a certain subkey or key. Services. Services are used to start processes at system startup. So you have an executable file that then is executed under a certain user. Normally these run within system user privileges, which are the highest privileges in the system, so they are a very good target for us. What kind of service accounts does Windows contain? Well, we have the local system account, which is another name for the system user. This system user has all privileges that you need. Actually, he does not have all privileges, but he has the debug privilege, which allows him to give himself every privilege. Then you have the network service account, which has some privileges, but is very useful also to get to system. And you have a local service account, which has the same privileges as the network service account, but cannot be used to authenticate to network services. Then another component, or two components, startup programs and scheduled tasks. These are very similar to services in that way that they also start up a certain executable file and run under a certain user. The difference is that they are not managed by the services manager, but by something else. Privilege escalation methods and techniques. So we are mainly covering Windows, although many of the principles and concepts that you're going to learn here can also be applied on Linux. In general, some techniques work for more than one component. I just mentioned that startup programs and scheduled tasks are very similar to services, which means that the attack vectors for these two components are also quite similar. And I'm going to use an attack tree to give an overview of the different techniques. So this is part of a bigger attack tree that I have created, and it shows you which different attacks there are to exploit an insecure service. So here you can see 5 different attacks. Some attacks need further requirements, like the unquoted service path or DLL hijacking, which we will get to know shortly. So let's take some examples. Weak service executable or configuration file permission, low-hanging fruit. So if we have a services executable file or a configuration file that is loaded by the service, and we can modify this file as a low privileged user, we can just replace or modify the file and then trigger a restart of the service so that our malicious file is executed. Demo time. How does it look if we do it on a system? So this is a machine that I have prepared which runs under Windows 7, but the concepts also work on Windows 10. So there is a service called Secure Service 2. And as you can guess, this service is not that secure. So if we go into that directory and check the file's permissions, you will see that users, which I am part of this group, are allowed to write and modify the file. So quite easy, I'll just rename the file, put in my own file, which I have prepared before the talk to save time. So what my malicious file does, I created it with PowerUp, with the PowerSploit module PowerUp. It creates a new user with a password that I know and adds this user to the administrators group. So I have now replaced the exe file. What do I have to do next? Restart the service, exactly. How can I do that? Exactly. I could reboot the machine. That would take too much time, so I've prepared a bat file which does restart all the services. So I'll just do that. Thank you. But before doing that, let me show you which users are on the machine. We have 5 users. I will now restart the services. Takes a little moment. Bloop. Now I will execute the command again. And as you can see, we have another user called sectest2. And this user is part of the administrator group. I'm sure you will believe me. Okay, this one was quite easy. Also, not that hard to understand attack vector are unquoted service paths. So what are unquoted service paths? As you can see, in the first orange box, we have a path to a file that, first of all, does not contain any double quotes at the beginning and at the end, and contain white spaces. Windows behaves a little bit weird when it finds such a path, because what it does is it tries to find an executable file where the first white space is located. So it tries to execute cprogram.exe. Why is it this way? I don't know. Maybe there's a reason for that, but and actually this was one of the vulnerabilities that I have also discovered on my own Dell notebook. So I had this super duper um, audio software which runs under system privileges. What else? And did not and had an unquoted service path. The problem with this vulnerability is that it's unlikely that you find a path where you have write access. So under C, you can create directories, but you cannot create any files. But for demonstration purposes, how does such an attack look like? So in this example, it's a little bit different. So we have, let me show you the service manager. We have again another very secure service called Secure Service 3. And if we look into the properties, you can see that the path that the file wants to execute is not embedded within double quotes and contains white spaces. So we have a white space at C program, and we have a white space at sec GmbH. So let's first of all try C. Let's check the properties, security, authenticated users, no permissions. Users, read and execute, doesn't help. So let's check the second path, or the next white space location, which is this directory. Okay, so I click on properties, security, I'm a user. Wow, I have modify rights. What a wonder. So we can again put in there our own malicious file called sec.exe. So what will happen is that, there we go, that Windows will try to execute C program files secure service 3 sec.exe. I reset the service, and I'm sure you all still remember how many users we had. There were 6 users, and now there's another user, sectest3. Perfect. And now to the third and last example, DLL hijacking. And as you can see already from the attack tree, it's a little bit more complicated. So, when is DLL hijacking possible? First, what we need is an application that again runs with high privileges and that tries to load a missing, or that tries to load a DLL file. The path to this DLL file must be relative, meaning it's not an absolute path, so that it has to search for this DLL file. And what Windows does is that it tries to find the DLL file in these directories in this order. So it starts with the directory from which the application is loaded itself. Then it goes to system32, system, Windows. Then it goes into the current working directory, which is the working directory of the user under which the process will run. Then directories in the system path environment variable, and then directories in the user path environment variable. In your opinion, which of these directories is the one where we could have write privileges, where we could potentially put in our own DLL file. Any ideas? Mhm. System 32. Unfortunately for that directory, by default you don't have any write privileges. That would be great, I know, but you're saying the last one. Okay. So what is the user path? The user path is the path of the user that's executing the process. So let's say we have a process that runs under system. Windows will try to find the DLL file in the user path of the system user. And it's a default user path, and probably we won't find a directory where we have write access to. Okay, let me spoiler you. It is the system path environment variable. So in the system path environment variable, you sometimes can find directories where you have write access to. Let's go to the demo. So what we have here is another very secure service. Secure service 1. Okay, there is no 1, but it's the first one. In here we have a secure.dll. Okay, but where is the binary? Ah, here is the binary. If I try to execute this binary, it says loading secure.dll. Secure now. So apparently it tries to load this DLL file. If you go back to this search order of Windows, it will try to find the DLL in the same directory. There is no DLL file, so it will continue the search. It will look in system 32, system C Windows, the current working directory, and it will not find the DLL file. So it will look in the system path environment variable. So let's check out how the system path environment variable looks like. That's it. From a first glance, any guess where I could potentially have write access to? Very good. In the Python directory. So if you look carefully, you can see C program files, C Windows, blah blah blah. But in these directories, I probably will not have any write access. So let's check the Python directory. So it's C Python 27. If I check the properties under users, only read and execute. Am I missing something? There's another group at the top, which I'm also part of, the authenticated users group. And here you can see that this group has write access. So if I go into the directory and try to write a new file, you can see it works. I have write access to this file. Very good. So you now have to help me. I have prepared this malicious DLL file, which also creates a new user. I'll put it into this directory. Am I done? Can I restart the service? What do I have to do? Exactly, I have to rename it. So what was the name? It was secure.dll. 1 second. Alright, so I will again go into the directory and execute the file. But now it says access is denied. What's the problem here? So my DLL file is apparently loaded, but I get an error. Come on, guys. What do I have to do? Hmm? Information to access the file? What am I doing when I execute the file with my user? I'm trying to load the file with my privileges, right? But I want the file to be loaded with the services privileges. Yes, exactly, thank you. So I just have to restart the service. So I will restart the service. Loop. And net user. And there you go, another user is created. Just one remark. Some people refer to this vulnerability as missing DLL. However, that does not have to be true as it is in this example. Sorry for that. So we saw that there is a secure.dll. However, if we again load the path system path environment variable, you can see that Python comes before the directory where the DLL file is in. So Windows first loads our DLL file before it loads the other DLL file. So don't call it missing DLL file, please. DLL hijacking is better. Great. What other techniques are there? Outdated software. So companies cannot always deploy patches in a timely manner. If you find a successful kernel exploit, you will have system privileges. So we will try to find a process or a kernel exploit. But if an attacker tried everything that he could, so he checked the services, he checked everything else, but he was not able to escalate his privileges, what can he do? It's a little bit hard for a penetration tester, but for an attacker, a malicious attacker. Correct, the answer is get some coffee and just wait, because the next exploit is awaiting. For example, on the 27th of August 2018, Sandbox Escaper, our infamous friend, again published a zero-day exploit for Windows. And this is his tweet. If you read through it, you can see he's angry in there. So on GitHub, so he published this exploit on GitHub, boom. Zero-day exploit for every Windows machine out there, without any exploit. Microsoft fixed this issue on the 11th September, which is around 2 weeks later. Which I think is still a very good job, because you as a software company have to understand the exploit, find a good solution to solve this vulnerability, do all the tests, and then deploy patches. But still, you have 2 weeks where you could use this exploit without any problems. And this was not the first and not the last time. Again in May, Sandbox Escape drops 3 more Windows zero-day exploits. Just some months ago. And this was again his message. I like burning bridges, I just hate this world. That last Windows error reporting bug was apparently patched this month. Other 4 bugs on GitHub are still 0 days. Have fun. And this happens again and again. So if you don't find any way to escalate your privileges, just wait a little bit. Low-hanging fruit, weak passwords. So you could crack or try to brute force these passwords or find plain text passwords in different areas. I once was in a security assessment for a German bank, and they wanted to assess their own Windows, back then it was Windows 7 clients. So I was trying all the different attacks with the more complex ones, but I didn't find any way. And then I thought to myself, hey, let me just, for the sake of it, try to find plain text passwords in files. So I was checking different files, and in this Windows punter unattend XML, there was a password. So I checked the user behind it, and I didn't believe it. It was a domain admin. So it went quite high up the ranks in this bank, and they got quite nervous because essentially everyone that had a notebook of this bank, including the external partners, could be domain admin within a second. So don't take this too, don't give too less attention to this kind of attacks. Also very interesting, insufficient physical access protection. So we all know, and we probably all done that, when a password is used for a certain user and the notebook is not encrypted, we can use our own Linux distribution or something similar and replace some files in the unencrypted disk so that the next time we start the machine, the password is gone or we have a system shell. But if there is an encryption, that will not be that easy anymore. So there are three attacks that are currently known, or that I know at least. I'm sure there are more. So the first one is called cold boot attacks. This was a video of a guy doing it. So what you essentially do is you start the machine, it loads the BitLocker decryption key from the TPM, it decrypts the volume, and then the BitLocker key is in the memory. And we all know that memory is a volatile storage, meaning if you turn off the machine, it does not directly lose all its data. And what you can do to increase the time that is required to erase the data, you can spray it with nitrogen, for example, to cool it off. And if you have, and if it's then cold, you can plug it into your own machine and extract the BitLocker key. So this attack is quite old. It's not something too new. Another example, and this one I actually had to try on a Swiss bank notebook. So they had a Lenovo T470S notebooks, and what we tried to do is a direct memory access attack. So it's a feature, no, it's called a feature, no, it is a feature that certain hardware can directly access the memory and does not have to go through the CPU. What is the benefit of it? You save a lot of resources and your PC is around 20 to 30% faster. So all the new laptops, machines have this feature. So what you need for a direct memory access attack is a FPGA board, as you can see in the picture, and this was my draft on how to do the attack. So the victim notebook had 4 different interfaces, a Thunderbolt interface and 3 M2 interfaces inside the notebook. So the Thunderbolt interface was disabled, but for the other 2 interfaces it was quite easy. Okay, you first of all have to know that there is a bottom cover detection on the notebook. So there's a small clipper, which if you remove the bottom cover goes up, and then you would have to enter the BIOS password. So what you could do as an attacker is to just cut off the bottom cover exactly where the snipper is, so that the bottom cover detection is not does not notice anything. We decided with the client that we won't do this because it's clear that it works and it's nothing that special. So what we then did is we replace the M2 interface, or we replace the Wi-Fi module of the notebook, which uses M2, and placed our own M2 card in it. So this in the end was the connection between the victim notebook and the FPGA board. Let me see up here. And as you can see, there are different cables, so we had to convert the different interfaces from PCI Express to Mini PCI to M2, etc., etc. I don't even remember all of the different interfaces there, but you just don't get all the cables. You have to order cables and then find a potentially working solution. And in the end it didn't work, and then we replaced a longer cable with a shorter cable, and then it worked. So it's quite a hassle. So yeah, when we did that, with the help of some nowadays open source tools, for example, the tools that Ulf Frisk published, credits to him, we were able to inject into the system our own code, or into the memory our own code, and had a system shell, as you can see here. Ah, not there. However, there is a GPO that was, I think, published 1 or 2 years ago, which is direct memory access protection. And this direct memory access protection prevented us from injecting our own code into the memory. But you are still able to extract the memory. And if you can do that, you will also find the BitLocker key. In the upper example, you can see a shareware tool that you would have to pay for, but it shows you that it did find the memory, the BitLocker decryption key, and we actually verified with the client, and he said, yeah, the 3 first digits are actually the BitLocker decryption key, are part of the BitLocker decryption key. But also with the volatility framework, you are able to get a key. We did not have the time to try out this key to decrypt the volume, but yeah, you could, if you don't want to spend the money on some, I don't want to say suspicious tool, but yeah, if you just want to save your money, you can try it out with volatility. It will take a little bit longer. This is the second attack. The third attack was published by Pulse Security, which is also quite interesting. So for the DMA attack, we needed hardware that costed around $1,000 US. For the TPM sniffing attack, you need around $50 to $100. So what you do is you sniff the BitLocker decryption key while it goes from the TPM to the memory. So you plug in some interceptors, and by that you could get the decryption key. You can read everything on Pulse Security's website. It's quite interesting. Good. So let's come to the privilege escalation approach. So in my opinion, this is how a privilege escalation approach should look like. The first phase is the general information gathering phase, where you want to know more about the system. You want to know what the Windows version is used, you want to know which service packs are installed, what the CPU architecture is, you want to know what the purpose of the system is, what is the system used for. You want to get to know the network configuration, and also what kind of antivirus software is used, what kind of security mechanisms are used, so that you get a really good overview of the system. In the second phase, called the method and technique iteration phase, we go through the attack tree, or through all the different attack vectors that exist, and try one after the other. And this again is divided into 4 steps. The first step is a small information gathering phase, where you just check is there a vulnerability, yes or no? If there is, you take the second step. You research and develop your own exploit. So you gather information about available exploits and customize them to the target. Please read the exploits, because if it contains things like RM minus RF, you won't be able to use your machine anymore. So yeah, try to understand, and this happened to me, so don't try that at home. What I would also recommend is to set up a test environment, because it's very nice that Metasploit or any other exploit database tells you this exploit works perfectly, but again, you would have to try it on the test machine. And if there is a service that you try to exploit and the service crashes after you try to exploit it, you will not be able to try the exploit a second time. So you should set up a test environment with the antivirus software that is used and make it as similar as possible. Also, consider possible security mechanisms. If you want to create a reverse shell, you should probably not use port 8080 or port 444, because this will be blocked by the firewall. Instead, use something like port 80 or port 443. In step 3, we try the exploit. In many cases, it will not work right away, so we have to go back to step 2, do some more research, further develop our exploit, and then try it again. And in the post-exploitation step, we document what we have achieved and all the results. And what is also quite interesting is to ask the blue team whether they have detected anything. In most cases they don't, but it's still valuable for the company that you're assessing to not only find out whether their notebooks are vulnerable, but also whether, or servers are vulnerable, but also whether they are detecting an attack while it happens. So there was one guy writing about his red teaming assessment in Twitter, and he said he was actually caught because he started PowerShell on a HR employee notebook, or it was a the employee was working in the finance department. So the IT department just noticed that something is suspicious because PowerShell was started on a notebook that should not start PowerShell, which is quite nice. Perfect. Let's come to the conclusion. So hopefully this knowledge can also be used by our dear system administrators and system architects. I personally believe that Windows has a great number of security mechanisms. It helps you to granularly configure privileges and access rights. So the privilege model in Windows is more granular than on standard Linux systems. And you have ACLs for registry keys, for processes, for files, etc., etc. Also, what I also think is that Microsoft does a good job in patching vulnerabilities in a timely fashion. Yes, there are some examples where, for example, the Google Zero project had to publish some vulnerabilities because Microsoft did not patch it, but I think these were merely some cases. So hopefully you have learned things about Windows, about privilege escalation concepts. You've got to know an approach for penetration testers, so that the next time you're doing an assessment, you will say, well, that escalated quickly. Before I finish my presentation, what I would like you to take with you, especially if you're a blue teamer, is that escalating privileges is just a question of time. Even if you did everything correctly, you set up everything in a secure manner, a new exploit will be published, and then someone will be able to escalate his privileges. So what is really important then is to detect this privilege escalation, or to detect this attacker. It's a hard job, I know, but that's the only thing that you can do. And the last thought is, although I'm talking about escalating your privileges, in many scenarios you do not necessarily have to escalate your privileges. So for example, if your goal is to get to domain admin, it is helpful to be local admin on a machine. But if you, for example, want to do attacks like Kerberos and get all the service, try to crack services passwords, you do not need to escalate your privileges. Great. Question and answers, please. Or questions if you have any.
There's plenty of time, so questions. Really? Everyone's still in coma from lunch.
Everything was so clear that there are no questions left. No, kidding.
Well, yeah, if there are no questions, well, thank you very much.
Thank you.